11 methods. We're going to look at chapter 1 and 2 revision sheet I gave you in class. And we're going to look at question 5. So this is page 1 of the revision sheet. So given two linear equations, we want to find the values for k, which we have no intersection, one section, and infinite intersections. Remember, whenever we have two linear lines, we've got to look at the gradient and y-intercept of each line. So, for example, if I were to rearrange this to y equals mx plus c, I would get 8y, and you can do this on the calculator if you want. 8y equals 24 minus kx. I'm just rearranging to make y a subject. And I got 8y, not 8y, I divide both sides by 8. So you get y equal to 24 divided by 8 is 3, minus k on 8, x. Okay. Similarly, we're going to do the same thing here. I'm going to move all the other terms to the other side. So make y a subject. So divide both sides by k. 12 on k minus 2 over k x. Okay, as you can see, my y-intercept here, or my gradient here, is negative k over 8. My y-intercept is 3. Okay, so that's for the first equation. Second equation, my gradient is negative 2 over k, and my c value is 12 over k. That's my y-intercept. Okay, so we've got to analyze this, okay, because we want known section. Known section means the lines are parallel, meaning they have the same gradient but different y-intercept. Okay, so first of all, in order to do all three questions, we're going to find when the gradients equal and when the y-intercept equal. So when do the gradients equal? So when do m's equal? Let's solve it. We want this to equal that. We want to find the value, which gives us a value. We want to find a value of k that gives us we want values of k which give, or value of k which gives us when the gradients are equal. So I'm going to go negative 2 divided by x, interactive add solve. So k equals 4 or negative 4. So k equals 4 or negative 4. When do the c's equal? Okay, we're trying to find when the values the c's equal. So I'm just going to make let's say we've got a c value of 3 here, and the c value is 12 on k. Oops, 12 on x. I'm just going to use x instead. Convenience. Interactive advanced solve. And k equals 4. Okay, so we're going to analyze. We know that the gradients are equal when k equals 4 and negative 4. Remember, we're for known section, they're parallel. They must have different y-intercepts. So if I let k equal to 4, the gradients will be equal, great, but also the y-intercept equal. We don't want that. So the only value which makes it have no intersections is when it has the same x-intercept, but different y-intercept. So same gradient, but different y-intercept. So the only value that gives me the same gradient is k equals to negative 4. Okay, but different y-intercept. For B, we want one section point. Okay, so the gradient must be different. So k cannot equal to, for the gradient to be different, k cannot equal to 4 or negative 4. Okay, so that's how I write. So it can be any value other than 4 or negative 4. For C, for infinite amount of intersection points means that both the x-intercept and y-intercept are the same. Because it has to be the same line basically, because it crosses forever. So k must equal to 4, because that's the only value which gives me the same y-intercept and same gradient. So hopefully that gives you an idea of how to approach this question. So first of all, you rearrange everything to make one subject, so you can read off what the gradient and y-intercepts are. Find when the gradients are equal. Find when the y-intercepts are equal. So find the k value, which gives you the same gradient and the same y-intercept. So and then you analyze. Okay, so if you want the gradient and y-intercept to be equal to the gradient and the y-intercept to be equal, then k must equal 4. If you want only the gradient to be equal but not the y-intercept, k must be negative 4. If you want for them to intersect once, then it can't have the same, it can't have a equal gradient at all. So it has to be not 4 or -4. So I hope that helps.